Okay, so we looked at people contributing to an annuity program, which resulted in a sum of money. That was the future value of the annuity. We could also use the word annuity to describe an account from which a person receives periodic payments. That is, if you invest a lump sum of money in an account today, so that at regular intervals you will receive a fixed sum of money. That's establishing an annuity. And so the formula is very similar. It just changes. I can't pick up my page. Instead of to the nth power, it's to the negative n power. But again, we don't really have to use that formula. We can use the graphing calculator. So we want to find the lump sum that one must invest in an annuity in order to receive $1,000 at the end of each month for the next 16 years if the annuity pays 9% compounded monthly. Okay, so let's think about what all we're going to be putting in here. N is 16 years, but compounded monthly, so that's 16 times 12. The interest is 9%, so 9. The present value is what we're looking for. The payments she wants to receive are $1,000, but that's going to be, so we're going to put in 1,000 here. The future value would be nothing because it's going to pay it all out over that time period. The payments per year would be 12, and so would the compoundings per year. And then when we get down to here where it says end or begin, this one says they're receiving it at the end of each month, so we would select end. So we're getting 16 years at 12 times a year. Interest rate is 9. Payment is 1,000. Clear that. Make that a 0. 12, 12. Whoops. Oh, 12. And we want it at the end of the month. So how much should we invest? $101,000. Basically. And 573. Suppose that a couple plans to set up an annuity with a $100,000 inheritance they received. Okay, so what is the size of the quarterly payments they will receive for the next 6 years? So this one, they are starting up with an annuity that's paying them out. So let's see what all we change. For the next 6 years, compounded quarterly. So this would be 6 times 4 at 7%. And this time it's starting with $100,000. And we're trying to figure out what the payments are going to be. And it's quarterly. And we're just going to assume that they're getting it at the end of the month. So I'm going to go back up here to payment. So this is how much they're getting paid this time. And they're getting paid $5,138.57. Okay. An inheritance of $250,000 is invested at 9% compounded monthly. If $2,500 is withdrawn at the end of each month, how long will it be until the account balance is 0? Okay, so we're going to be trying to find that. We know the interest. This was $250,000 invested, and you're getting $2,500, and it's compounded monthly. And we want to know how long it's going to take, so we're looking for N. So I'm going to press alpha, enter, and this would be 180, basically 6 months, which I'm going to go back. 186 divided by 12, that's going to be 15.5 years. Because that makes more sense to think about it that way. Now let's look at bond pricing. Bonds represent a relatively safe investment similar to a CD, a certificate deposit. But unlike CDs and like stocks, bonds can be traded. And the trading or the market price can fluctuate. Usually they're issued by governments, corporations, and municipalities for 10 years or longer, which means you have to leave the money in there for 10 years or longer before you can get money back. In the simplest case, a bond's issue price or par value is the same as its maturity value, and you get paid your interest semi-annually. So, for example, if a corporation plans to issue $5,000 bonds at 6% semi-annually, then the maturity value is $5,000. Whoops! Whoa! Dropped my camera. But you'd be receiving $150 semi-annual coupon. The coupons are paid at the end of every 6 months. So that constitutes an ordinary annuity. At maturity, the bondholder receives the final coupon payment of $150 plus the $5,000 maturity value of the bond. So let's think about this one. Suppose a 15-year corporate bond has a maturity value of $10,000 and coupons at 5% are paid semi-annually. If an investor wants to earn a yield of 7.2% compounded semi-annually, what should he or she pay for this bond? Ooh. Okay, so let's think about this. First off, let's talk about that coupon payment. How much is that going to be? So they take the $10,000 and we're going to take the 5% semi-annually, and so that ends up being $10,000 times 0.05 divided by 2, and we get $250. So the investor wants to earn a yield of 7.2% compounded annually off of that $10,000. So, well, actually, you're going to get $10,000 of the maturity value, right? So how much should be invested to get that $10,000? Well, that would be if we took that $10,000 and we wanted to figure out the present value of it at 1 plus 0.072 divided by 2, and he's leaving it in there for 15 years, so 2 times 15, and we figure out that present value of just how much interest it's earning, right? So I'm going to use the app for this. This is in there for 2 times 15, an interest rate of 7.2. The present value is what we want to know. What we're talking about right now is not talking about the coupon payments. This is just that investment of getting that maturity value of $10,000 when it's mature. So after 15 years, it's worth $10,000. That would mean its present value is $3,461.05. Now, what about those coupons? Well, those are the payments of $250. let's do that at the 7.2% interest. So for the same amount of time, we want to know the present value for just those payments, ignoring that money. So what's the present value of those payments of $250 at a time? Well, that present value is $4,540.94. So this would be called the bond's market price. Would be the sum of those two together. Whoops, I hit the wrong button. 3461.05 plus 4540.94. So he should only really pay $8,001.99 for this bond. That would be selling at a discount. This has to be the case in order for the yield rate to exceed the coupon rate. Similarly, if the yield rate is lower than the coupon rate, then the market price of the bond will exceed its maturity value. And that's when bonds are selling at a premium. So we also want to talk about the present values of annuities due. And that's when payments are made at the beginning of each month. I'm not going to go through where the formula comes from, because like we've said, we can do this in the calculator a lot faster. So a lottery prize worth $1.2 million is awarded in payments of $10,000 at the beginning of each month for 10 years. Suppose money is worth 7.8% compounded monthly. What is the real value? So we're trying to find that present value. Okay. So in the app, compounded monthly for 10 years. So 10 times 12, 7.8%. We're trying to find the present value. Being paid at $10,000, and the future value is $1,200,000, and it's compounded monthly, but we get the prize at the beginning of the month, and we get that its present value, and I think I messed up somewhere. Hold on, let me see where I messed up. Let me pause this. I know where I messed up. We're just talking about the payments, how many payments they made. So it would not have a value for future value because it's going to be paid all out. Oh, that's where I messed up. The present value, the real value, is that they're only really paying this much. So that's how much is being spent to pay $10,000 at the beginning of each month for 10 years. So while you actually are receiving a total of $1.2 million, because the money is actually compounding interest, this is all that the lottery company actually has to pay to start with. Suppose that a court settlement results in a $750,000 award. If this is invested at 9% compounded semi-annually, how much will it provide at the beginning of each half-year period? So this time we're looking for the payment. We do know the present value of this one. And it's for 7 years, half a year, at 9%, and we're looking for how much we're going to receive. And it's half a year and it's the beginning of each time, so we keep it on begin, and it says that we will be getting 70,205.97 half a year. Now, a deferred annuity is one in which the first payment is made not at the beginning or end of the first period, but at some later date. And so, all right, so to do a deferred annuity, we have to do it in 2 steps. So step 1 is we need to find the present value of the expected payments. So the deferred annuity will pay $10,000 per quarter for 15 years after being deferred for 5 years. Okay, so, and this is being done quarterly. Okay, so if we're wanting to make the, whoops, let me go up here. 15 years is how much we're wanting to get paid, and they're paying quarterly at 6%. We are looking for that, we're going to be looking for the present value, and it's quarterly. And this one didn't say if it was going to be at the end of the month or at the beginning of the month. So if it doesn't say it, then we're going to assume it's going to be at the end. So we want to know the present value of that account. So I get that the present value, or the present value when you start getting the payments, is $393,802.69. Now we need to know how much needs to be put in there 5 years earlier to have that much after 5 years. So step 2, present value to have that after 5 years, because we're waiting before the payments come out. So this is only going to be for 5 years, paid quarterly, and we're looking for the present value to have a future value of $393,802.69. And I got 292.386.85. So that's the present value of an annuity that would give you that. Suppose a lottery prize of $50,000 is invested by a couple for future use as their child's college fund. The family plans to use the money as 8 semi-annual payments at the end of each 6-month period after payments are deferred for 10 years. How much will each payment be if the money can be invested at 8.6% compounded semi-annually? So since this one's a little backwards, we need to see how much that money is worth. It's deferred for 10 years. So that this one, we're given the present value. We want the future value after 10 years. Okay, so let's see. we're going to defer it for 10 years, and it's semi-annual payments, so times 2 at 8.6% interest. The present value is $50,000, and we're looking for that. Compound it semi-annually, and it did say end on this one, so that's good. The future value of that investment is going to be $116,052.95. Now we want to know the payment that they'll be getting for 8 payments. Okay, so 8 payments with the present value of 116.052. Whoops, not point. Oh my gosh. 052.95. We're looking for the payments to use it all up. And so they'll be getting $17,451.26 semi-annually.